Here we'll be installing the CPM, which is cranking power monitor, onto the battery of this 4-cylinder car. This is a 1.8 liter engine. Should be a good display demonstration for our CPM. Here you can see after the connection that the battery power is at 12.8, which seems to be very full. But how will it perform with the cranking power required to start the engine? Here, after the engine is started, you can see that the system voltage is 13.8. After this, we'll be turning off the engine and then restart it. So the CPM have collected enough data to analyze and show the actual capacity left inside the starting battery. And after the engine is turned on again, we can see that the display shows P40, which means that the battery's capacity of starting power is at 40% only. Although the voltage seems to be very full at 12.8 volts, it does not really show the actual state of the battery itself. And this seems to be a very small battery compared to what the engine is requiring. So the output right now is really insufficient. You can press the button on the right bottom side of the CPM, where you can go back and forth from capacity of percentage like P40, or you can press for another 2 seconds and you will be able to see the voltage. Here we can see the inside for the remote monitor of the CPM. As you can see, it is P40, which is the same as the display on the CPM module that is mounted on the battery itself. By pressing the right side button again, you can display the percentage once more. And the reason it's flashing is because this is a warning that the battery is under capacity and should be recharged to full as soon as possible. Here, you can see that we'll have added a jump starter to the starting sequence. Before it was P40, now with the jump starter added, it's P60. The reason for the increase in percentage in the starting battery capacity is that the jump starter itself is a 9 amp battery. Although not very big, it does boost the starting power, so that we can see the starting battery itself is really insufficient. Now we'll be testing the jump starter only. You can see here that the starting cables are hooked directly to the jump starter only. Because this is a new battery hooked up to the CPM, it will take 1 cycle to 2 cycles time for the CPM to record and fetch the data from the battery, from the engine again, so that it will be able to calculate correctly. Here you can see that after the engine is turned on the second time, the jump starter's battery power is really insufficient. It's far below the normal capacity level. It shows ERR here. It's because it's below 5% of the starting power. With the CPM design, any battery powered below 5% will show ERR to let people know that you should remove the battery and change a new one, or charge immediately so that you will not have a suddenly fail battery. 你要来看一下吗？你看，它现在虽然是这样子哈，
发动2次 ER 就可以，因为它的启动能源真的不足它来用，所以你可以发动的时候是哼一下，这样非常的慢。然后我们现在再按。
Even after the engine is turned off, the CPM will still work as long as it is attached to the battery itself. It will be recording constantly, and the memory will have recorded and stored the percentage of the last cranking start. Here you can see that it still records ERR, which shows that the last cranking power is really insufficient. So driver will be able to know before they even start the engine that they should change battery. Here with the Mercedes-Benz, where the battery is hidden away from view, you can still connect the CPM. Here you see that the CPMs will show P60. After the cranking start,